This is the video for section 11.5, Inscribed Angles. Please follow along with your video worksheet. The first section has all of the terms, definitions, and diagrams that I will be using, and the second section has all of the example problems that I will be showing you. Please fill in the worksheet as you watch the video. Let's begin. An inscribed angle has its vertex on the circle and its sides contain chords. So, this is an inscribed angle that you're seeing me trace in blue. Its vertex is A, which is on the circle, and its sides are ray AB and ray AC, which both contain chords of our circle. So angle BAC is an inscribed angle. Now, angle BAC's intercepted arc is the arc right here that you see in yellow, which is arc BC. The measure of an inscribed angle is equal to half of the measure of its intercepted arc. So, for shorthand, we write angle equals arc divided by 2. And this is the formula we're going to be using for all inscribed angles. Example number 1. You're given a diagram here and we are asked to fill in all of the blanks. First of all, angle AQB, which is this angle right here, is a blank angle. Well, its vertex is at the center of the circle, so we're going to be calling that a central angle. Next, its intercepted arc is the one you see in yellow right now, which is arc AB. It is a minor arc because it's less than a semicircle, so we're going to be using 2 letters to describe the arc. Next, we need to find the measure of arc AB, and since it's a central angle, the arc's measure is going to be the same as its central angle's measure. So, the intercepted arc, arc AB, has measure equal to 140 degrees. Next, we're asked to find the measure of arc ACB. Now I'm tracing in blue arc ACB, which has endpoints A and B and goes through C. Now, the yellow arc and the blue arc together make an entire circle. So, to find the measure of arc ACB, I am going to take 360 degrees, which is the measure of the arcs in the whole circle, and I'm going to subtract off 140 degrees, which is the yellow arc, and that should give me the measure of the blue arc, which is 220 degrees. Moving on to question 2, we're given a diagram. And now we're given angle DEF, and we're asked to say what type of angle this is. So I'm tracing now in yellow angle DEF, and if you notice here, the vertex of angle DEF is at E, which is not at the center of the circle anymore. E is located on the circle, and the sides of angle DEF contain chords. So, therefore, angle DEF is what we call an inscribed angle. Now, its intercepted arc, I am tracing in purple right now, and its intercepted arc is arc DF, and it is a minor arc because it's smaller than a semicircle, its measure is less than 180 degrees, so we're going to be using 2 letters to describe that minor arc. Next, we're asked to find the measure of angle DEF. Now, angle DEF, we said, was an inscribed angle. So, using our little shorthand from before, the measure of the angle equals the measure of the arc divided by 2. And remember, we're going to use this little shorthand for all of our inscribed angles. So our arc is 115 degrees. We divide that by 2 to get the measure of the inscribed angle, which is right here at 57.5 degrees. So the measure of angle DEF is 57.5 degrees. Last, we're asked to find the measure of arc EF. Arc EF is being traced in blue. And if you notice here, the purple arc, 115 degrees, and this green one up here, which is 137 degrees, and the blue one, all together make an entire circle. So the measures of all 3 of those arcs should add up to 360 degrees. So if I want to find the measure of arc EF, I'm going to take my 360 degrees and subtract off the 115, which is the purple arc, and subtract off the 137 degrees, which is the green arc. And when I do that, I get the measure of arc EF as 108 degrees. Moving on to question 3. We are given a picture here, and we are asked for the measure of 2 arcs. Now, if you look at this angle right here, angle GHI. Angle GHI is not an inscribed angle per se, but its vertex is on the circle. So, because its vertex is on the circle, I'm still going to be using my little shorthand here that says the measure of the angle equals the measure of the intercepted arc divided by 2. And we're going to be using that whenever our vertex is on the circle. Not necessarily just when we have an inscribed angle. So, in purple here is going to be the intercepted arc for this yellow angle. Now our angle has measured 88 degrees, so its arc is technically going to be double that measure because the angle is half of the arc. So our arc here is going to be 2 times 88 degrees, or 176 degrees. So the measure of arc HJI is 176 degrees. It's the purple arc. The next arc they ask us to find is the measure of arc HKI, which I am now tracing in blue. Now the purple arc and the blue arc together make an entire circle. So if I want to find the measure of the blue arc, arc HKI, I'm going to be taking the entire circle, which is 360 degrees, and I'm going to subtract off the measure of the purple arc, which is 176 degrees. When I do that, I get 184 degrees as the measure of the blue arc, or the measure of arc HKI. Moving on to question 4. In question 4, we have a triangle that is inscribed inside of a circle. And we're being told here that M is the center of the circle. So, the first thing we're asked to find here is the measure of arc LPN, which I'm tracing in yellow. Now, if M is the center of the circle, that means that segment LN right here is a diameter. And if segment LN is a diameter, then the yellow arc, which is arc LPN, is going to be a semicircle. Since it is a semicircle, it has measure 180 degrees. Next, we're asked to find the measure of angle LON. Now, angle LON is being traced right now in purple. Now, if you notice, angle LON is an inscribed angle, so its measure is going to be equal to half of its intercepted arc, which is the yellow arc. So the measure of angle LON is therefore going to be 90 degrees or a right angle. Next, I'm asked to find the measure of arc OL. Now, arc OL is right here, traced in light blue. And if we notice here, it is the intercepted arc for angle ONL, being traced now in green. So since that blue arc is the intercepted arc for an inscribed angle, its measure is that inscribed angle's measure multiplied by 2. So that gives us 34 times 2, or 68 degrees. Next, I am asked to find the measure of angle OLN. Angle OLN is being traced in yellow. Now, angle OLN is going to be an inscribed angle also. Its intercepted arc is being traced in blue. It's arc ON. So, if we want to find the measure of angle OLN, we can take half of the blue arc. Now, in order to find that blue arc, we notice that all the arcs in the circle add up to 360 degrees. So, if we look back here, this one in green was a semicircle. It had measure 180. This one right here in purple has measure 68. So if I want to find the blue one, arc ON, I take 360 minus 180 minus 68. And when I do that, I get 112 degrees. And that is measure of arc ON. Now I'm going to use that to find the measure of angle OLN right here. It is an inscribed angle, so its measure is half of its intercepted arc, which is the blue arc, 112 degrees. So I'm going to be taking 112 degrees divided by 2, and that will give me 56 degrees. Now, just as a little quick check, we see that a triangle inscribed in the circle. The three angles in a triangle should add up to 180 degrees. So if I take 90, which is the measure of the right angle, and I add to it 34 degrees, and then I add to it the 56 degrees, I get 180 degrees, which is the sum of the interior angles of a triangle. Moving along to our last question, question 5. We have a diagram here that shows O as the center of our circle, and we have a triangle that's inscribed inside of that circle. And we're asked to find X as well as the measures of the three angles A, B, and C. Now I'm going to start here by noticing that since O is the center, this arc that I'm tracing in yellow is a semicircle. So it has measure 180 degrees. Now since it has measure 180 degrees and this angle right here that I'm tracing in purple, angle ABC, is an inscribed angle. It has measure half of its intercepted arc, so half of 180 or 90 degrees. So the measure of angle B is 90 degrees. Next, I'm going to go ahead and look at my triangle. And the sum of the measures of the angles in any triangle is going to be 180 degrees. So I can solve an algebra problem here that says 2x plus 90 plus 3x minus 10 equals 180 degrees. Collecting my like terms here, 2x plus 3x is 5x, 90 minus 10 is plus 80 equals 180. Subtracting 80 from both sides, I get 5x is 100 degrees divided by 5, and x equals 20 degrees. And I'll fill that in under my answer blank. Next, I need to find the measure of angle A. Now, angle A has measure right here 2 times x. Now, x was 20 degrees, so measure of angle A is 2 times 20 degrees, or 40 degrees. And likewise, the measure of angle C is 3x minus 10, so it has measure 3 times x, which is 20 degrees, minus 10. 3 times 20 is 60, minus 10 is 50 degrees. This concludes the video on section 11.5, Inscribed Angles. Thanks for watching.